That's part of this. All right. Forces quiz number 1. What is the units of force and its definition? Okay, well, the unit is newtons, symbol N. What is its definition? This is kind of a weirdly worded question. I don't know whether they want me to define the unit or actual force. If they define the unit, I guess it's a kilogram meter per second squared. If you said that, I'd take a mark. If you're defining force, I guess if you said mass times acceleration, or if you said a push or a pull. What else did somebody say? I'll give you marks if you throw it out at me. Sorry? I can't hear you. A vector? Vector, there's lots of other things that are vectors. I'll give you a half mark for that, but not a full mark for that one, kiddo. Sorry. Because acceleration is a vector, velocity is a vector, and force is not velocity. They're different. It is one of many vectors. Any others? Okay. What net force? So we're starting off very simple. We're just saying, hey, you need to know that F equals ma. And if the car is 1,200 and the acceleration is 2, then the net force, I'm multiplying by 2. I guess I really don't need a calculator. 24,000 newtons, yes? 2,400 newtons, Mr. Dewick? How about I'm multiplying by 2? I really don't need a calculator. Nice try. How about 2,400 newtons? 1 mark. Number 3, artillery barrel. Okay, they want the force, so I'm going to start out by saying, well, the force is mass times acceleration. I know the mass. I don't know the acceleration. However, I do know that. And I know that. I know that. So it seems to me I can find that. I've seen about 12 people writing things down like mad. I'm sensing people didn't do this quiz. Or maybe you had trouble with number 3. What's an equation that has D, VI, VF, and A in it? I think this one. I think this one. I think it's going to be 770 squared minus 0 squared, which I guess I probably didn't need to write, all over 2 times D. When I crunch the numbers, this one I do need a calculator for. Why did I write a D there? D is 1.5, Mr. Duke. Since I'm plugging in numbers. I get 197,633.33 meters per second squared, which seems high, but then I went, no, it's an artillery shell. That's got to have a heck of an acceleration, I think. There's a reason they do damage. So I'm going to write down 1.98 times 10 to the 1, 2, 3, 4, 5. 1.98 times 10 to the 5, but I'll carry that number on my calculator, and that's going to go right here. The force is going to end up being the mass, 65 times 1.98 times 10 to the 5th. Multiply that times 65, and you get 1.28 times 10 to the 1, 2, 3, 4, 5, 6, 7. Newtons. If you got that, that gets you 3 marks. Otherwise, I would give you 1 mark for the answer. I would give you 1 mark if I saw that you realized that we needed to find the acceleration. I'd give you a half mark for writing F equals ma, and I'd give you a half mark if I saw this equation somewhere. If you had clued in, that's what I need to find the acceleration. Number 4, a net force of 12 newtons is needed to push a 1.2 kilogram object. What's the acceleration? Well, if F equals ma, I'm pretty sure that A equals F over m. It's going to be 12 over 1.2, which I'm pretty sure is 10 meters per second squared. Is it 10? Yeah? Good. 1 mark. Turn the page. A rocket engine uniformly accelerates a rocket ship from rest to a final velocity of that in 30 seconds. What's the average acceleration? Oh, well, A equals, what is it, VF minus VI over T. I think I know VI is 0. VF is 3.2. T equals 32. This is a nice review of some stuff from last unit. It's going to be 3.2 minus 0 divided by... Oh, I didn't even see that. Times 10 to the 4th. That seems like a little slow rocket ship to me. Makes way more sense. Times 10 to the 4th minus 0 all over 32. I think this will work out evenly. I think you're just going to end up with 10 to the 3rd, 100, I think. But let me see. 3.2 times 10 to the 4th divided by 32, 1,000, not 100, 1,000. Yeah, 1,000? 1,000 meters per second squared. That's actually some pretty good acceleration. 1 mark. What's the average net force? Well, F equals ma. 4.5 times 10 to the 4th. 1,000. And I get that. 4.5 times 10 to the 1, 2, 3, 4, 5, 6, 7. 4.5 times 10 to the 7th. Units, it's a force. Newtons. It's fine, except I think mine's way easier to write than that. Number 6. A net force of that acts on that. If it accelerates to a final velocity of that, how far did it travel while accelerating? Okay. They want me to find that. Well, I know V initial is 0. I know V final is 12. You know what? If I can find the acceleration, then I'm good to go. I can use the one that has VI, VF, and A and D in it, the squared, and VF squared equals VI squared plus 2AD. Do I know the acceleration? I think the acceleration is going to be force divided by mass. I think the acceleration is going to be 1.6 divided by 6.4. I think the acceleration is going to be 1.6 divided by 6.4. It's going to be 0.25. And now I can use VF squared equals VI squared plus 2AD. I can rewrite that. D equals VF squared minus VI squared all over 2A, I'm pretty sure. I think. 12 squared minus 0 squared all over 2 times 0.25. 12 squared minus 0 squared, I guess I didn't really need to type that in, all divided by 2 times 0.25. 0.25. Let's, come on. 2, there we go. 5, there we go. Y'all get 288? Is that what I heard Perry say? Meters. 2 marks for that. If you got it right, you get 2 out of 2. Otherwise, I'd probably go something like this. I'd probably give you a half mark if I saw that you'd found the acceleration. I'd give you a half mark if I saw that equation somewhere, a half mark for sticking in the numbers, and a half mark for the answer. Now, if you got the wrong acceleration, but you went velocity squared minus 0 squared divided by 2 times whatever acceleration you got, and you did that right, you can get 1.5 out of 2. What is the time of acceleration? I think I'm going to use t equals v final minus v initial all over a. I think that's the easiest one. You could also use the d equals vit plus a half at squared. It's a quadratic. I try and avoid that one unless I have to. V final, William, is 12. V initial is 0, all divided by an a of 0.25. Are you going to get 48 seconds? Yeah? Because dividing by 0.25 is the same as timesing by 4. I guess I would go 1 mark if I saw that, 1 mark for the answer, or something like that. And then I would turn the page. A book is sitting on a level desk. Think your binders. Which of the following statements are true? There are no forces acting on the book since it's not accelerating. True or false? What forces are acting on the book? Gravity and? No. Oh, so the net force is 0. That's what I could say because it's not accelerating. Oh, in fact, I could say that for part C. The net force is 0. That's going to be true. B, the magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. I think that's true. How do I know? It's not sinking into the table like quicksand. It's not leaping into the air like Superman. The friction force is what's holding the book on the desk. If your desk was made of ice, could you still put your binder on it? Then false. That would make sense, what with it being worth a total of 2? Sure. And 4 things? Yeah, let's call each of those a half mark. Well played, sir. Well played. Elevator. I like elevator questions. You're going to have 2 or 3 on your test. I guarantee it. Okay? How do you do this? Well, I read it. A 60-kilogram person stands on a scale that reads the normal force. If the person and the scale are inside the elevator, find the scale reading. So really what I'm asking you to find, if I say find the scale reading, what am I really asking you to find? What do scales measure? They don't measure your mass. What do scales measure? They don't measure your weight. What do scales measure? Measure your normal force. They measure your normal force. So when I say tell me what the scale is, what I'm really saying, Riley, is find the normal force. You know what? I need a good free body diagram. Jake, here it is. What are the forces acting on it? Get the obvious one. Darn right. Normal force. Why do you think normal force is winning? What's your hint? That word right there says there must be a winning force in the up direction. Who's winning? Who's the loser? You did. I need to get the normal force by itself because that's what a scale measures. AJ, how would I get the normal force by itself?
You add gravity to the other side.
So are you saying I get normal force equals ma plus mg? I agree. And then if I plug in numbers, I think I'm going to get a mass of 60, an a of 1.2, plus a mass of 60, an a of 9.8. Isn't it negative 9? No. We used winner minus loser. We took care of the signs with our winner minus loser. We don't need to put the negative in there. It's going to be... Oh, I think I can do this in my head. 60 times... 660? So if you got that, you get 2 out of 2. Otherwise, I would probably go something like this. I would give you 1 mark for that, a half mark for that, and a half mark for the answer. Did I actually give you marks for the free body diagram? No. Does it help and make it easier and take all of 1 second to sketch? Yes, it does. All right. Oh, B. Perry, my friend, which way is the elevator accelerating in B? Here's my free body diagram. Get the obvious one. Darn right. What else? Normal force. Why did I draw the normal force shorter? That's losing. Reminds me of that. In fact, my equation, it's almost identical to A, except it's going to be winner minus loser equals MA. I still want to get the normal force by itself. I think I'm going to go yoink and yoink. I'm going to plus that and plus that. I think I'm going to get this. I think you're going to end up with, Matt, the normal force equals mg minus ma. It equals, what was m? 60 times 9.8 minus 60 times 2.25. Uh, 453? Yeah? C. Elevator moves up at a constant velocity. Okay, here's my free body diagram. Gravity down. Normal force up. It's accelerating, or sorry, it's traveling upwards. Doesn't say accelerating. It's traveling upwards. I'm going to assume normal force is winning. Now, technically, I'm wrong. I think it's going to end up being a tie, but the nice thing about this method is even if you kind of guess wrong, it takes care of itself. So, Dylan, maybe you read this in a hurry and you went up. I'll let the normal force be bigger. Okay, you'd go like this. Winner minus loser equals ma. But, Dylan, my friend, the fact that it's a constant velocity, what does that mean for the acceleration? It's moving constantly, so what's its acceleration? As a number. Sorry? 0. So if I hear you, you're saying that? Yeah. Oh, by the way, the marking scheme for B, same as number 1. Same as A. So 1 mark for the equation, 1 half mark, half mark. I think what you're then saying, Dylan, is this. Winner minus loser equals 0. Is that what you're saying? In fact, I would plus the mg over, and I would say Fn equals mg, which is going to be 60 times 9.8. It's going to be 588. What that really means is once the elevator hits a constant speed, you can't feel it moving in your gut anymore. You might hear it, and you might hear clicking as it travels because there's, you know, the railings aren't dead even. You can hear some stuff, but if we had a perfect elevator and your eyes were closed, you couldn't tell. D, elevator is accelerating downwards at 9.8 meters per second squared. Okay. mg, definitely winning. Normal force, my equation is going to look like this. mg minus Fn equals ma. Again, to get the Fn by itself, I'm going to plus it over to the other side and minus ma over at the same time. I'm going to get this. mg minus ma equals Fn. And Tara, when I crunch the numbers, I get 60 times 9.8 minus 60 times 9. Oh! You get 0. You are not massless in free fall. You are weightless in free fall. We call that apparent weightlessness. True weightlessness is if we stick you away from any planets in outer space, far, far away, where gravity can't reach you. But apparent weightlessness, yeah, we can do that all the time. Now, if you didn't show your work, if you just read that, by the way, and you said, it's 0, full marks, 2 out of 2. Same with C. If you read, hey, constant velocity, I know that means that you're just going to feel mg. Great, I'll give you full marks, but this is how I would prove it if I needed to. Number 9, snow. A 47-kilogram cross-country skier is moving horizontally over packed snow. The coefficient of friction between the snow and the skis is 0.11. If the skier can exert 110 newtons of force, what's her acceleration? This is a job for a free body diagram. mg, normal force, F pole or F applied, yoink, friction. Who's winning? I think the force from the ski pole. Who's losing? Friction. And that equals my net force, ma. The pole, it says, is 110 minus friction is what times what? mu times the normal force. That equals ma. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Which one? mg. Cool. So I can go 110 minus mu mg equals ma. How would I get the a by itself? I think I'm going to divide by the mass. Yeah. I'm going to get this. The acceleration is going to be 110 minus mu mg divided by m. The acceleration is going to be 110 minus 0.11, 47 times 9.8, all over 47. I got more than one number on the top. I better use brackets. All over 47. Do you get an acceleration of 1.26? Yeah? No? Yeah? Units? It's acceleration. So if you got that, 3 out of 3. Otherwise, I'd probably go something like this. I'd give you 1 mark if I saw that. I'd probably give you 1 mark if I saw this, and 1 mark for the answer. If you forgot the units, you get a half mark off. Last one. Number 10. A 20 kilogram box sits on a floor with a coefficient of friction of 0.32. What force is required to move the box across the floor at a... You know what, Dylan? I think this is an important phrase right there. Because if it's at a steady speed, what do I know? I know that, but what else does that tell me? Come on, reach back. You came up with this about 2 minutes ago. I know you can. What's the acceleration? That's going to come in important when I do my winner minus loser. Whether there's an A, it's a 0. I'm going to do a free body diagram. Let's see here. I'm pretty sure a box is acted on by gravity. I don't think boxes sink into the floor like quicksand. We're moving the box. This is the applied force. And it talks about a coefficient of friction, so I guess there's friction in that direction right there. You notice without thinking about it, because I've done so many of these, I drew the friction and the applied about the same length. Why? Because what did you tell me my overall acceleration is? I think it's going to be a tie. In fact, some of you may be getting the hang of this enough that you may just say, hey, Mr. Dewick, I know my equation is going to be F applied equals friction, but just in case, I'll show you the long way to get there. Curtis, you might have said, well, it's moving to the right, so I think F applied is the winner, and you could have gone like this, and you could have said friction is the loser, and you could have said that equals MA, but then Dylan would have tapped you on the shoulder, and he would have said, hey, that's a 0, and you would have said, oh. So you're saying, yeah. And then you might have said, oh, why don't I just plus the friction to the other side? In fact, why not, instead of writing that, don't I just write that? Isn't that clever the way I did that? Sure. What's the applied force? That's what they're asking me to find. Friction. Oh, friction is what times what? Friction is mu times the normal force. I know mu, 0.3, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. What? Sorry, I didn't hear. What's another force the same size as the normal force, folks? mg. So I can say if I want to move this box at a steady speed, 62.72, is that right? 0.32, 62.72. I'll go 62.7 newtons. In fact, really we should say 63 because there's 2 sig figs for the coefficient of friction, but whatever. If you got that, you get 3 out of 3. Otherwise, I would probably go something like this. 1 mark if I saw that. I'd probably go 1 mark if I saw that, and 1 mark for the answer. If you would be so kind as to give yourself a score tally out of 29. Last day we were looking at many body problems. Problems with more than one mass, and we had just introduced you to the Atwood machine. We said the trick for a many body problem, for a problem with more than one mass, is pretend you don't have more than one mass. Because they're attached by a rope, we know that they will accelerate at the same rate, which means we can go winner minus loser. But it's going to be winner minus loser equals the mass of all of them. Then if they want me to find any of the individual forces that were in my big free body diagram, I go look at one individual mass and I deal with that. Just give me a second here. I got to shoot somebody, don't I?
Yeah.
So we left off looking at here. Example 3 says find the acceleration of these systems. Ooh, one has numbers. One says a mass of 3m and the mass of m. We'll try doing it algebraically. Now, if you have an algebraic one and you really don't like it, you could let big M be 2, let's say, and then you'd have a mass of 6 and a mass of 2. Or you could let it be 10, have a mass of 30, have a mass of 10. The only thing is, if you're ever making up numbers because it's algebraic, don't use a 1 because you may think something canceled when it didn't, because when you multiply by 1, your answer doesn't change, and you may say, oh, it canceled. Maybe it didn't. So I find it easier to, 2 and 5 are usually my fallbacks, or 10. I can follow those through and see what happened. Anyways, let's try this. I'll zoom in on the left-hand one, nice and big for you folks. Let's label our forces. So we're going to call this M1G, and we said tension. And we're going to call this M2G, tension. And now you have to just use some common sense. Who's winning? Which mass is going to start falling downwards? The heavier one. That much I have to expect you to come up with on your own. Sorry. The heavier one. So when in my drawing then here, anything that ends up pointing down is going to be winner. Anything that ends up pointing up on this side is going to be loser. You got to be careful because this is pointing up, but when it gets to this side, it's not going to be. My equation is going to look something like this. M2G minus tension plus tension minus M1G equals, do I have more than one mass on the left-hand side? Then I better have more than one mass on the right-hand side. I better. Why am I relaxed? I'm getting rid of tension. And what did they want me to find in example 3? Oh, let's see if we can, on this same line, also say, how would I get the A by itself then? How would I get the A by itself, Michael?
I would divide M2G minus
The left side,
by M1.
the bracket. Would that be a quicker way? The left side by the bracket? Yeah? How about we'll just say, let's divide the left side by the bracket. Justin would have come up. Oh, sorry. Acceleration equals M2G minus M1G divided by both of them. Now it's plug and chug. I mean, not the easiest plug and chug. You got more than one thing on the top. This is where, this really is why I went on that rant at the beginning of the year about getting a good calculator. It was for questions like this because it's way easier to see where your brackets are and what's on top, what's on the bottom. But it's going to be 5.7 times 9.8 minus, it was 3.5 times 9.8 all over whatever 5.7 plus 3.5 is. Brackets around the top, brackets around the bottom, and I'm deliberately not going on my calculator. You want to see right now for your own practice, assuming you all have a calculator here, get it out, and you want to see if you can type this in successfully. I'll freeze the screen so you can't see what I'm typing and somehow mooch off me. I think I'll freeze the screen, or maybe my projector battery, my remote Uh-oh. Maybe the battery finally died. Oh, there, that worked. Of course, I might not be able to unfreeze it. That might not have been too smart, Mr. Duke. I think you get an answer less than 5, bigger than 1, less than 4, bigger than 2, less than 3, bigger than 2, between 2 and 3. Yeah? Yeah? I think you get 2.343478, 2.34. Now, by the way, units. First of all, it's acceleration, meters per second squared. By the way, notice how I write this and how I type this. I find that when I'm writing, brackets make me more organized instead of writing a times sign, because when I write a times sign, it looks like an X, and my math career has taught me to think it's an X. But when I'm typing in my calculator, I'll put a times sign there, because if I put a bracket there, and there, I can't keep track of what's on the top and what's on the bottom. So I try and de-emphasize brackets on my calculator, but I use them to emphasize stuff in my handwriting. I think that's a good way to go. Next one. Well, M1G, tension, M2G, tension. What do you think is going to fall fast? Or which do you think is going to fall? 3M or M? I think the 3M. The winner is M1G, so it's going to be M1G. And then Tara, I run into a minus tension, yes? Oh, and then I run into a plus tension, because that tension comes all the way around. Yes, yeah. And I run into a minus M2G, and that equals, 3M plus M times A. Love it when tension vanishes. What is M1? That's going to be 3mg minus big mg equals, what is 3m plus m? I think 4m, isn't it? Right? It's 3m plus 1m. 4m? Yes? 4m A. Oh! Do you guys notice anything? Well, on the left-hand side, I can gather like terms one more time. On the left-hand side, I have 3mg minus mg. What would 3mg's minus 1mg be? 2mg's. I think the left-hand side can simplify to and I think then we can say, you know what? That happens. Cool. And then I can say, how would I get the A by itself? How would I get the A by itself? Divide by 4. So you're saying go divide by 4, divide by 4. And I think we're going to get this. A equals 2 big M over 4. Although I probably wouldn't write it like that. What's 2 over 4 in lowest terms? You know what? Your acceleration is good. Oh, no, the M canceled, Mr. Duick. Sorry, not an M there, a G there, a G there. Good gosh, Mr. Duick. That's my fault, guys. The M canceled, a G there. I think A is going to be G over 2. It looks like you're going to accelerate at half the rate of gravity. 9.8 divided by 2, which I think is 4.9 meters per second squared. Connor, that was purely algebraic, and I did that so that you could see it's scary but not hideous. Having said that, if you're uncomfortable with the algebra and the gathering-like terms and the stuff that we did, let big M be 5. 3M is 15. And now you've turned it into this question. Example 4, last one, says find the acceleration and the chord tension if mass 1 equals that and mass 2 equals that. Okay. Try this one on your own. Now remember, we use both masses to find the acceleration. To find the tension, you go look at one mass. If you can't remember, go check your notes, see if you can figure it out. I will slowly do this up here, so I'm not going to freeze the screen. So if you get stuck, you can look up and see if you can figure this out. Tension. Let's double check. Mr. Duke. First of all, did you copy the masses down right? Yeah, you did. That. So for tension, it's going to be who's winning. For mass 1, tension is winning. So plus it over. 12.5. And did I type this in right? 24.6 times 9.8 minus 12.5 times 9.8, close bracket, divided by 24. Am I right? Is that, anybody else get that? No? Yeah? Oh, okay. Take your time if you need more time. I went in a hurry. You don't have to do it as fast as me. Sorry? Did you?
Running with retention was part, but then I realized we were looking for retention.
Yeah, it's a part. There was two part to this, right? It said find the acceleration, and then there was the word "and," which would imply more. The chord tension, which is a second object contained in that subject-object sentence with the conjunction "and." They don't do that in communications. People still going? Keep going. Take your time. How many of you got that? Ooh, a few of you only. Okay. If you need more time, take it. But there's the answers. Those of you that are done, let me just quickly tell you what the homework is, and then you can continue working on this. I'll put this back up, and you can work on the homework. Hey, if we turn the page. Number 1, 2, 3, 4, 5 is good. So far we haven't skipped a single thing. 6 is good. 7 is good. Okay. I'm going to assign 8 to see if you can get it. It's tricky. It's tricky. Okay. Tomorrow you can expect another take-home quiz. It still won't have multi or many body problems on it. It'll still only go up to friction. All right. There's about 25 minutes left. You can work on the 8 questions. You can get caught up.